desktop right now, and then we are good to go. Does it look okay, Lauren?
Yes, it looks fine.
Okay.
It looks. We can see the poster. Yeah.
Yeah, I see it with a red line around it. So that is not the intention, but okay, let's see what happens next. Okay, yes. Well, thanks for the introduction. Let's pick out this one single one-liner, simple rules, creating complexity. That is really what is at the basis of all our work. And all our work is not only architectural, it actually also applies to the artworks of Ilona. But in this lecture, I mostly focus on works of architecture. And I show some works that we did together. In the context of the book I'm writing, I think this is the most important message. I mean, back to normal, no way. We're going to have to look at every aspect of society, actually how it works, how it functions. It's political, it's technical, it's about emotional issues. And we have to design, as designers, the components actually to make this work, to make this other world, this other universe, this other normal work. So that is one of the phrases that will occur frequently in the book, that another normal. So what another normal can we think of? I was thinking back a television program on Dutch television called The Chinese Patient. It was a long time ago, 40 years ago. And this psychiatrical patients had a few rules for a better society. And I think this is very interesting. Well, he was thought of as a fool, but in the end, I don't think he was a fool, because this is what he wanted. He said, I want clothes made of wool. I mean, the real thing. He wanted the food to be better. And okay, that is imaginable if you live in a hospital, I think. But also it really refers to the atmosphere of today. We want better food, and we want to fight obesity, etc., all over the world. So I think this was very visionary in many ways. These two are very well accepted. The other two are maybe less accepted as a vision. We want to transport by limousine. I mean, luxury transport. This I will link later in the lecture to automatic and autonomous transport. Not so much by limousine, but actually having the comfort of traveling without effort and actually working while traveling. The last thing is the most controversial, I think. China, one big villa park. Basically, it means that he wants the best for everyone. He wants everyone to have a good house in a good environment and a nice green environment, possibly. And I can only agree with him. So whether that it's in a big city with a lot of green around and good parks, or whether it's in the countryside with affordable housing, that's of course a question, but I do very much agree with this point. The title of the Another Now refers to the book of Yanis Varoufakis. I can recommend to read this book because I think it's a visionary, it's original, and actually it has a lot of valuable ideas for what he says, the another now. So I obviously borrowed the Another Normal from the title of his book, Another Now. And the question is, the open question is a post-corona question. What is then a new normal? What is another normal? What is that another now we can think of? I was thinking of 10 points. No, I didn't count actually. Is it 10? Yeah, I think these are 10 points for another normal. And it all has to do with that idea of simple rules, creating complexity, but also creating fairness and equality and equal opportunities for all. Many of these are probably debatable, so we can do that. But I think especially the combination of different of these points will sure guarantee or at least form the breeding ground for a better world to live in. So let's have a look at this one first. It's not about my work, this one. Actually, only when we come to robotic production, it's really about our work. But I still have to mention all the others because they are linked to what we do and they follow similar principles. So this one single rule of universal basic income, or ubiquitous if you want, actually is a simple rule that actually makes many other rules with many exceptions superfluous. And of course, we can use the value-added tax from the bigger companies to provide for this basic income. There is money enough. That's not the problem. It's more the problem, how do you divide the money and how do you divide it in a way that also it's fair to what people do, what they do for work, for example. And you have to keep in mind that artificial intelligence will take away many jobs. These are the jobs to the left. Repetitive jobs, routine jobs, jobs that can be automated or optimized. And of course, we as designers, we stay in that area to the right, where you have complexity and creativity that is needed, much needed, actually to work with the new machines, with the computers, with the robots, etc. So a robot doesn't replace people. No, people will get new ways of living, of working, etc. And basic income, of course, helps a lot for many people to become part of that new normal. Well, here you see also what the AI is capable of, and that's why it will be automated, and that's why thousands of millions of people will lose their jobs. In Qatar, I had a discussion with a local architect, and he expected that 1 million of the expat jobs, that is actually the workers for infrastructure and the stadiums, will lose their jobs and will be replaced by machines, and that only 10% of the jobs will remain. And I think he's right, this will happen. So we have to work with this. Ubiquitous land rights is another thing that I think is important for a fair basis. This is an image from Dubai, I think, yeah, this is Dubai, where people, the Emirati that is, not the expats, are entitled to have a piece of land for free. They don't pay for it because they are Emirati. So it's a variation, it's a capitalist variation of communism, actually, that the land belongs to the people. The land doesn't belong to private owners. But so this is a combination, it's private owned, but you are entitled to get your share. And that share in Dubai is quite big. It's more than 1,000 square meters. You can build anything on it. And you can use the garden for growing stuff. This is the Dutch variation of the same, actually, but in a different form. So this is, what was the name again? Minitopia. And people can get this piece of, well, abandoned land, or not even land, it's more like a former waste area, and they can have it for a number of years and build their house without the need to invest heavily in it or to have regular expenses, yeah, to the banks or to the lending companies. And These houses are typically small, so that's very different from the Dubai variation, but I think it can point in the same direction. Potentially is a good idea actually to provide for a lot of pieces of land, and why shouldn't we? Because the cows number of cows have to be diminished, so a lot of land will become free for other usage, and I think giving lots to the people is a very good idea. And actually, this was one of my ideas when I did my thesis project in 1979, that was, where I had this strip that was hanging over Holland and actually indicates an area with a certain shape that allows for people to have a piece of land, and like a birthright, you just get it. And at another plan in the same period, I had this design for the polder, which is now the Flevoland, now the Marker Waard polder. Well, it didn't happen. It's now a nature reserve, which is actually a better idea. But there was a competition for this, and then I had this XYZ system of endless pieces of land available for the people. And this is really a different story than traditional urban planning. It's actually allowing for growth. One simple rule, again, it's just one simple rule to have a piece of land and then get your freedom within that single rule and create complexity from that simple rule. I think it works like that. I think it also would work for energy, water, and food production. So I have a few examples of our thinking, early thinking, I have to say. This is an urban design we did with Ashok Malhotra, a well-known urbanist in Holland, from Indian origin. This is a project we did for Dordrecht, where we had 1,500 houses that produce their own food and even produce food to export. So it's also a little, small factory, a town as a small factory. At the top, you see a parking. All the cars parked there. They produce actually CO2, and that will be used for the glass houses. You see patio homes, you see row housing, freestanding house, the whole range, normal range actually of housing. And you see bigger pyramids, but all of these elements, all of these typologies produce food. This one, patio housing. So you live on ground floor. And that was one of the ideas. Maximize the idea of usable space on the ground floor and use the roof for growing food. And this is both collective and individual. So it's a merge actually of production and consuming. The other example in the food production chain, that has to be brought as close as possible to where you consume it, because that is the basic idea. Produce anything as close as possible to where you actually use it or eat it. In this case, this is the greenhouse. I think it's in Utrecht. Yeah, it's in Utrecht. I see that bank over there. It grows all the food for the vegetables and the herb, the kruiden, the herbs, herbs for the restaurant downstairs. I think it's a very good idea. So let's apply the same idea to energy. So produce energy where it's used. You can see this, you can consider this at 3 levels, I think. National level, so produce where in your country, in your area, whatever, instead of importing gas and be dependent on the Russian pipelines, etc. So I think that's a good idea, and why not? This is again an example from Dubai. They really invest in this. And of course, much of it is a PR activity in Dubai, but still they are serious about it. This is an example from Holland. the same urban designer, Arthur Balotra, designed this city. I forgot in which city it is actually, but it's south of Rotterdam somewhere. It's a city that produces its own energy, a neighborhood rather. So that's the second level, the neighborhood level. The third level is, of course, your private level, your house or your apartment building. That you say, okay, this is where I live and I produce energy. So the idea is now, when we divide the responsibility for producing energy, each 1/3, so say national installations do 1/3, community does another 1/3, and the private persons, they do another 1/3. So if you have that together, you bring that together, I think it would be an easy target to manage the clean production of energy. So as close as possible to where you live. But again, we have to consider all the different scales where you live. It's not only your house, it's also your neighborhood, it's also your city. Water production is, of course, well, just as important, actually, but more difficult to actually obtain, to create water. How do you create water? In countries near the sea, they do, for example, desalination plants. They take it out of the sea. That's a possibility. We can do that too in the Netherlands, of course, but there are other areas where it's much more difficult, like in the desert. Then they have to squeeze it out of the air. So by condensation, they have infrastructures like this, and these produce actually, well, tens or hundreds of liters of water, potable water, drinking water, per day. So it would help. If it's enough, I don't know. You need quite a lot, actually, of these. But it sure is an helper. And if you do the same strategy like 1/3, you do locally, close to your home, it might work. This is the interior of the Dutch Pavilion in Dubai, the World Expo 2020. 2020, they still call it, but it's 21. And in the Dutch Pavilion, it drops water. It's not really rain, so this is a lot of PR again. But actually, they use the same technology or a similar technology to actually harvest water out of the humid air. And air is humid in those areas, so there's a good potential for that. From the outside, it looks like this. We haven't been there yet. I think the pavilion is terrible. And also I show you our own take on the pavilion because we entered the competition as well. But this idea, of course, is good. But again, it looks very much like greenwashing, otherwise very polluting activities. This is the pavilion that we designed ourselves. It actually does exactly what I described in the earlier points. We produce energy here, by and large on the highest level, but also by integrating solar panels in each of these components. We produce food for the restaurant, like the example that I showed you, and we produce water. And the theme for the public is actually to go through this pavilion via 3 trajectories that explain everything about food, water, and energy. And it culminates in the top where it is actually produced. But we didn't specify exactly how. We did some calculations, but we didn't make it to the final round, so it stops here. The other idea in this pavilion, and you can see it's a very particular way of designing, is to have one component for floors, for balustrades, for facades, for anything, basically, in a parametric system that fits to all situations. So with one component parametrically designed and robotically produced, we can make anything. And this making anything is really an important issue because complexity is no longer something that is exceptional, but complexity has become something that is normal. It's the new normal, that new another normal, which emerges out from simple rules. So basically, you cannot do much simpler than this. It's really one component, and the position of that component, the array, the numbers, the frequency of the number of components, the position of it, defines what exactly is the shape and what are the dimensions and what are the level of perforations, etc. So this one component fixes everything. Here's an example from Qatar again. This is an abandoned office building, and we were asked to join a competition to see how you can redesign this in a sustainable way. So then off to the left is the building as it is. It's still like that, so the competition is not decided yet. To the right, you see what we did, what we proposed. I said, okay, I have these three elements like farming, water harvesting, and energy production. I put three extensions on top of this building and to produce what is needed for this location. Yeah? And it's quite a big thing, so these extensions are quite big. I think this looks to me very much real. What is the task? Which is actually the challenge if you are really serious about producing more locally and consuming what you have produced locally. The building becomes bigger, also more transparent, and it becomes a small factory almost. Each building, a house, an office building, city, and this, of course, you would need an architecture to unify this into one structure, but that's another story. It's first about the calculations, what is exactly the need for the production of food, water, and energy. Okay, let's look at autonomous transportation. These are one of the other elements that needs to be linked to the previous ones to become successful. Because none of these issues is a standalone issue. If you decide to go 100% for only one of these, not much will happen. Only when you link everything together, it will become something more successful. So this picture shows the real situation of inner cities. I think it's quite evocative. The pavement is very small. The street is just an abyss. Yeah, it's a big canyon. You cannot go there, and going to the other side of the streets is also a challenge and quite risky. Automated vehicles, autonomous, these are vehicles that are looking to each other, like the birds in the swarm, exactly like that. They only look to nearest neighbors, and they measure distance, they measure speed, they measure direction, and they adjust to each other. No one is leading. So if one of these cars steps ahead and goes to the front, he will be looked at by the others in the same way as he is looking at the neighbors right now. So that's the condition of the swarm. And that swarm should actually, or let's take this picture first, that swarm should actually include people. So it's not about cars looking at each other, it's also cars looking at people, people looking at people, and and cars looking at cars, of course. So everyone looks to everyone. This is the new condition of our society, where everything is connected via these small signals that are being sent and processed and received. Nothing special. We live with this condition. It's not Big Brother. Actually, it's the opposite of Big Brother, because there's no central authority. It's just everyone looking at everyone. And backspace, this one, yeah. And if you are autonomous, the car, it might look like this. And actually, I would quite appreciate if it would look like this, because you step in your car and the car brings you where you want to go. And in the meantime, you just chat with your friends or your work, or you do anything to use your time more efficiently. But you don't lose time in traveling. This would apply to many forms of transport. Actually, it's like the train downsized to individual vehicles. The original idea of the swarm and swarm theory is this from Craig Reynolds. It's early or late 60s, I'm not quite sure. And he was able to program the swarm, because that's what you have to do. And these small triangles, they are looking at each other, and they are aware of each other. And they follow simple rules, like birds in a swarm, simple rules that create the diversity of the swarm. And simple rules apply to the behavior of people. Actually, like we do now, we look at our smartphone, we keep distance. It's a reality. And we have to find ways to make this less obtrusive, to make this just normal in a way, but not as a central authority that is actually controlling our behavior, but that we control our behavior ourselves. So it's not like this from a Minority Report, where Tom Cruise passes some billboards and he is addressed personally by these billboards. I mean, the billboard just knows him because they scanned his eyes, so he is known by the billboard. And then he proposes perfumes or any other thing for him to buy. The other image from Minority Report, which is one of my favorite films, because I think it's so much predicting in many ways what is happening. And not surprisingly, these ladies in the fluid are called the precogs, and they are trained, part of their brains are trained to foresee the future. Now, this is frightening. This is not what we should go or develop into, but there's a lot of sense in sort of predicting what will happen if you are connected. When everyone is connected, predicting what will be a logical or normal next step is doable. And then if you know that, if you can predict it, you can also prevent eventual casualties. What we see now in the Corona crisis, I think it's a disaster, because many people don't want to be connected. I think that's the main thing. Be connected, and I don't mean the 5G, the 5G shots or something, that there's something in it, but I mean that you have to connect via small devices in a way that you can adjust your behavior according to a situation. So keeping distance is one of those, and avoiding big crowds is another thing. And this can be organized just by crowd control that comes from the crowd and not from top down. This is of course, this is an issue for debate, I know that, but I think there's a lot of logic into that. So now we come to the major part of the lecture, which is actually the robotic production part. and the parametric design part. It started here, work by Ilona. It's called folded volume. You can, I won't explain everything, but it's more the method that we are looking at to make things. So it's about making, world making, so to say. So we had this digital sketch. Ilona did a digital sketch, points in space. We connected the points. So here's the connection again. And we connected in such a way that we have about triangles and sometimes quadruple, 4 angles, sometimes even 5. 1, 2, 3, 4, 5, 6 even. And then assemble them to form the whole. So this is, in very short, the method that we have applied since for almost any of our projects. So it starts digital, then you have to translate your digital sketch into components, and then you assemble the components to form the larger picture, the larger whole. And this was meant as a sculpture, but also we could see it as a prototype for a larger building. So this happened in 1991, so this is 30 years ago. 10 years ago, I did this project for a climbing wall where I had this component developed much farther, fully parametric. So the previous one was much more analog, actually, very experimental. This is fully scripted. Each component of the climbing wall is different, but all of these components are looking to each other and they adjust to each other to form the bigger picture. In the script, you also measure the angles. If the angle is too big, you have this red alert, which you see in the left. And then we have to adjust the model manually to reduce those excessive angles, because we don't want exceptions. We want to have a system, and which sets the guidelines, which sets the framework, and we want to work within that system. And that system is based on this one single rule that creates pleasant kind of diversity, where every single component can be different, not necessarily, but can be different, and is assembled to form the whole. And it's just as simple as that. You have this stack of components that you put on the ground. They are all numbered, they all have their identity. This is crucial. Everything needs to have an identity. Like every computer has an identity, like every cell phone has an identity. Every single component that connects to another component has to have an identity. It's not the emotional identity I'm thinking of, but it's simply something that is needed to be addressed, to receive information, to process information, and to send out information in a different form, which is a difficult way to describe a dialogue. So this is what happens. Then what can happen, and what we realized in many different versions, simple components that can create a form of complexity that you otherwise would not be able to do. This building, the cockpit, so most of you must have seen it. It's along the A2 highway close to Utrecht, between Amsterdam and Utrecht. It's a showroom for luxury cars, but I have to tell you, it is not an expensive thing. And that's the main issue here. So we use this technology to transform complexity into the norm, into that other norm. Only because we can control the system from scratch. We can control the system from scratch with the maker, which is the steel manufacturer. So it's not this traditional design process that the architect has an idea, and then the idea is scrutinized by other people, maybe calculated by engineers, and then tendered, and then there's a contractor. It's not like that. No, it's design and built. You have to work together from scratch. Otherwise, it's simply not possible. So, but if you work together, you can synchronize your working methods, and that's exactly what we did. So we scripted this building, all the components, they are different, they're all different. We scripted the components in such a way that we could communicate the exact data directly to the machines. This is machine-to-machine communication. Some views of the building and then some more detailed ideas of how it is made. Okay, luxury cars, but the building itself was just standard price. This is really exciting that is possible. Now here you see some views of the interior. The interior is a loop. It's a loop. Let me see. Well, nice pictures, always good to see nice cars. We are very interested in cars, by the way. Not so much of the power of the engine, but very much for the styling. And we look a lot at cars for styling instruments. I will show you some examples later. So these are some images of the interior. And the loop can be best showed. So browse quickly through these. The loop can be best showed by this model. This is how it started. So we have 4 levels. So Hessing had 4 brands, so he needed 4 levels. And what I did is to connect these levels to each other in an endless loop. And that's how you see these cars actually going up the slopes and finding their positions. It's really fun. And this guy also liked that very much because he was a driver, a racer for this is how is that called? It's in Africa, these races. Dakar, I think, Dakar. And contested in those races. The cockpit that I showed is only part of a bigger thing, which is an acoustic barrier. And here you see already what I meant with looking at cars. And you really have to look at these fault lines, which are normal in cars, but not in buildings, really. And what they do, these fault lines, is reflecting the upper part, reflecting the sky in the upper part, so it looks more light, and reflecting the earth in the lower part, so it looks darker. That makes it much more elegant, and so it makes the building look longer than it is, and that's what we want. We want to have this very much stretched idea of the 1.6 kilometer experience driving past this acoustic barrier. And driving past means that you experience changes in the geometry, the slow changes, gradual changes from convex to concave, pumping up where the cockpit is, and then fading out again, etc. So 60 seconds of experience. Now here you see a car, a very nice design of Romeo prototype by Vermeers. Louis, I think it's his name, Vermeers. It's not a production car, I think, but it does exactly what I was talking about. The upper part reflecting the sky, the lower part becomes darker. And this is just to show what actually happens when you pass by. Left and right is almost synchronized, so you see what happens when you the cockpit, it pumps up, and then you have the difference in convexity and concavity and folding, fading in, fading out. Well, that's the idea actually. One component that actually adjusts to this difference in geometry, the pumping up of the volume. And these are the 2 very simple details that are at the basis of it. But remember, none of these is the same. each of these nodes is different, has its own number. Each component and subcomponent has its own number and are connected to each other in this one particular way. All these, which is, this comes out of our scripts. So all these triangles for the glass plates, they all have their unique dimensions. Doesn't look like it from here, but sure it's true. Same for the cockpit itself. We processed the whole design in ProEngineer. Today, you would use Grasshopper, as we did for the climbing wall. And here you see the painfully exactness of every single node, and the data are extracted from this node and communicated with the machines. So all these differences in angles, all the dimensions of the components, subcomponents, all the parts, the position of the bolts, everything is in this detail. And this one detail actually is the building. There's nothing else. This is it. So this is the extreme simplicity, simple rule that creates the diversity. And don't think it's difficult to make, it's not. You can use any workshop and use your inventiveness to build a machine to control all these angles. It's not difficult, it's actually very doable. And it has a lot of advantages because you don't need a lot of other players. And you don't need many consultants, you don't need that contractor that is subcontracting the steel manufacturer. You work with the steel manufacturer directly. And he has the calculation office to make all the calculations for the nodes. You don't need Arab or any other engineer for that, really not. Building a prototype is necessary to see how it behaves. And this is very typical for any larger project, that you build prototypes first. And if it's okay, then you're good to go and you start assembling it. Just a few people doing 30 meters a day, or building up the acoustic barrier and building up the cockpit. So you see how it works. And you simply connect one component to the other and it builds itself. You don't need scaffolding. So the vertical components you see there, it's not a scaffolding. They don't bear the structure. They just are for checking the dimensions. And here you see the two structures being built and approaching each other. We had two clients, one for the cockpit, one for the acoustic barrier, and we synchronized the two clients into one structure. They didn't have to talk to each other. And then it comes together. Smoothly, effortlessly. And you see the folding lines being transferred from the acoustic barrier into the cockpit. But these are two separate buildings. They don't even touch each other. They don't have to. It's just the visual aspect that has to be continuous. Well, you can actually recognize a good building if their logo of the building is actually connected. If they use the building as their logo. That's what they call iconic, of course. But this is literally iconic. And they use it as an icon, which is a sort of sign. And then iconic in this sense, I very much support, and it means that the building has character. It's not about being strange or being wild or being just decorative in some way. No, it's about being essential and being able to use the essence of the design as an icon. More examples, smaller pavilions like the IWeb in front of the faculty. Again, one building, one detail. Assembly of the components. So I can show many of these projects, and they have the same principle all over, but they're all different, and they don't even look like each other. This is the interior, where we used the polyurea foam for the insulation and for the seating arrangement. The building itself forms actually the seating arrangement around the central arena, which is the virtual working space. We use this as the proto-space laboratory of hyperbody. This is the Balna, so you pronounced it properly. The Balna in Budapest, this is the interior. So here we have the same system, seemingly the same system, because it has been as the cockpit, but it has been made in a different way. Actually, they used welding on site, which I was very much against, and which caused some imprecision in the whole structure. But from a distance, it looks okay. It's also considered as a very successful merge of the traditional and the new, and the public, and actually also the critics and experts, they really like this building as much as we do, actually. Okay, let's have a closer look at the idea of the components. So each design deserves its own components, its own unique component, and it's always different because it really depends on what you are designing. So here we try to do with a number of students, we try to have a component, that one component that is part of the swarm of components that does everything. And that does the insulation, that has the windows if you need to look outside, that has the properties for the structural properties, that has the tactile properties, that have everything, the aesthetics, etc. The styling issues. And we came up with this proposal. We called it Prototype 4.0. We wanted to build a new pavilion, but unfortunately, due to the crisis and the reduction in budgets at universities, we didn't get the budget to build a new pavilion for ourselves, so we had to limit ourselves to a prototype. And an aspect that is especially important here, and it's important for anything you do, actually, is the connection between the components. It's not the component itself that is important, but actually just as well the connections between the components. So this is the analog version, the connective analog version of communicating in real time, the connectedness via sensors and actuators. So in the static building version of connectivity, it's just as important to look at the connection, and the connection has to be integrated in the system, not something additional, no wet connections, only dry connections, to be able to assemble it and also take it apart and build it somewhere else again if needed. And that's what we did, of course, many times. And the last time we used it was in the conference in 2016, where we used it as a stand for the lecture. And one of these components actually was interactive. That's the component in the front. That one comes down when the speech is done, and then there comes a new person on stage, then it pops up again and it forms the lectern. And you can put your laptop on top of that one. So that is also part of the functionality of components. Some components can be fully interactive, to interact with the user. And that makes this single component ID very rich in the end. So you can do anything with it. You can apply any functionality to the component in a parametric way that you can actually play with it, play with the parameters, play with the dimensions, the performativity, etc. Again, it's not difficult. It's just a matter of teaching yourself Grasshopper, in this case, and then do whatever you want to do. It's almost a democratized way of designing, because basically the way of designing is also open for other parties. It's very transparent way of design. Also, it's an inclusive way, and it allows for participation, which is also one of the main things, the main promises of interconnectivity between things and people. This is an example of interactive installation. Interactive mirror. Close it in.
Gus, your sound is not good.
Get you out. It's not difficult to imagine.
Gus, your sound is not good.
Oh, we can do without sound.
No, it's better now.
Yeah, sure. But because this was the video sound.
Oh, okay.
So forget about the sound. It's not important. Okay, then we apply it to many other buildings. This is a building in Abu Dhabi, and you see it has a completely different look. But again, same principle. Same principles of that component that is leading everything, leading the main structure, leading the facade, interior finishing, everything. And it really works on all levels. The client wanted to see the steel because it was an offshore builder. He really liked the presence of these steel structures. So that's why we left it exposed. Now, a completely different thing, because we are talking to first-year students. So this is a first-year project done at the Qatar University, and these students didn't know anything about computation, but it was interesting to see how we could teach the principles of parametric design in an analog way. So I asked them to I have to say, because I did this together with Ilona, we asked the students to find a component that is different from other components, so not a repetitive, not repeating component, but a unique component, and put them together in any way to design a big urban public sculpture. So you have to imagine these are 60 meters high, placed in a public space, also be interactive in some way. So you see completely different interventions by the students. One had his dancer, and the dancer actually would respond, would turn around and respond to the public. There you have a parametric design, the middle one, that is just as well parametric, because you can define the relations between the components. So parametric design is not necessarily fluid shapes or something, not at all. You can do parametric design in any shape. It's the principle that counts. The principle is that you have to build connections between the components following a simple rule. Well, she did this complex of cubes that are all different, and we used it as a climbing tower. And to the right, I don't remember exactly what that was. It was, anyway, it was with mirrored discs that are all different. This one was interesting to the left. It was at the times of the blockade that Qatar was blocked, was actually almost wiped off the map, almost, by Saudi Arabia, UAE, Egypt, and number four countries. Bahrain, yeah, also was in that joined that blockade, and so they were fully isolated and had to find ways to do things themselves. They had to find ways to produce their own milk, for example. So this refers back to how I started, that it's very essential that you can produce your own basic food, and also applies to energy. Well, Qatar has a lot of that, and also water. And the students were very upset by this movement, this blockade, and became very much supportive of their own government, because the own government was very positive responding to it. They imported thousands of cows and started their own milk factories, no longer being dependent on Saudi Arabia for the milk and other stuff. So they started to become very aware of the importance of autonomous production for the country. So that's one thing that is important. The other thing is the community in your own immediate neighborhood, your immediate house, I would say. You have to produce stuff as well. So she, to the left, she used the Qatar as a contour, and she used these mirrors. It's also a way of parametric thinking. These mirrors of different size and depths in the relief to evoke that idea of that diversity that this new situation actually created. And I think that's very interesting. So it was a negative rule, of course, the blockade, but it triggered a lot of good things, a lot of diversity inside the isolated Qatar. Students were very political at that time and still are. And that has been very interesting to witness, and also it gave a boost to Qatar as a society to improve on many levels. For example, to improve on the conditions of laborers. And that's what we're actually doing right now. So there are more examples using triangle. Another very political student to the left who was actually spinning threads between the interior boundaries, because it was locked up in this frame, this blockade frame, and then all these relations that are created inside that imprisonment, so to say, and actually the diversity and the richness that's created from it. Very interesting stuff. To the right, you see another thing. I think it's quite more fun than exactly very interesting, because she used these paper discs, these plates for food, to make this sculpture, which of course evokes that idea of that new museum of Jean Nouvel in Qatar. So how people like it very much in a way. The other thing we ask students is to disassemble daily products. And actually, it's amazing how much you learn from that, because I asked them to actually disassemble a few products. And this was a lantern, I think, and we also had other household products into the finest detail, everything. I asked them to describe each component. So these are components or subcomponents sometimes in case of these screws. But most are components that are customized for design. They are not regular products from the shelf. They are designed for this particular place on this particular spot. And I asked them to also describe the relation that these components have with their neighboring components. This was very instructive for the students to actually understand how things work And then if you understand how things work from the component level, there's always this idea, the design level, of course, but then the design has to condensate into this component level, and all these components are uniquely designed and actually interact with each other, either in real time using electricity or just as fixed components that have to fit into each other. And the most interesting one was this one, that we disassembled a vacuum cleaner, a robot vacuum cleaner, and how that worked. Also, I asked the students to put it together again, to make it work, which was the biggest challenge, of course, but most of them succeeded. So it was very interesting. The other project I want to show you from Qatar is this robotic project we did. So here you see Ilona, and that was our friend Jasmine in Qatar. She's an architect. And we use these robots, these vacuum cleaners, to create two paintings. One additive, you add paint, and one subtractive. You subtract flour from a field of flour that we distributed on the floor. Here you see how it works. So we connected acrylic marker at the end, vacuum cleaner, and additive painting, and we programmed the other vacuum cleaner to actually go in circles for the subtractive painting. So these robots can be programmed. That's interesting. So you can actually use them as your own extension as a painter. The last project I show in that we did in Qatar is this project called New Babylon. It's actually, no, it's called the Little Babylon, sorry. And it's an inflatable sculpture with real-time behavior. It responds to Twitter messages in some way by interpreting the Twitter messages, the words from the Twitter feeds, and actually organize these words into 4 moods. And then when certain words extracted from these messages are dominant, then the structure would actually go into that mood. And the 4 moods are, if I remember well, this was done in collaboration with Rezone from Den Bosch, and they did actually programming of the mood. We did the sculpture itself. And here you see some of the behavior. It does 2 things. It changes mood, and also it changes sound. You don't hear it right now. It changes the character of the sounds, and then it also changes its shape. Because the sectors in the middle are alternately deflated and inflated, and then it deflates it lower, the whole thing, almost crashes it, and inflates different levels of interaction. Now, this project I really want to show also because it's an ongoing thing. It's not built yet, so we are working on it, but it's an interactive sculpture for Qatar. It's built on the idea of a sign in the stars, a constellation of the Big Bear, and these stars, they shine in different strengths, different radiosity. They shine on luminosity, and they have different distance towards the Earth. And so we define a three-dimensional sculpture which reflects these parameters, and then connected them with accessible tubes. There's an infrastructure inside, so you can go from sphere to sphere, and these spheres are actually representative of the achievements of female people in Qatar. So it's a monument for feminism, basically, and it's accessible for everyone. So in these platforms, there are projections of 7 different themes. That's also why it's called the 7 Daughters. And 7 comes from this storyline from that's Qatar history. And the desert people were always looking to the stars for orientation. So the Big Bear was an important one of those. And they had this story of the 7 daughters, whereas 7 of these stars were visible all the time, and 1 star was appearing every now and then disappearing again. And this star is then the so-called murderer of the father of the 7 daughters, and the 7 daughters were always chasing this murderer. So this is a continuity at the night skies, and they connect the story to it because this murderer appears every now and then disappears again. So it's this continuous story of the good and the bad, I think. But we applied this to the rise of the culture of the how you call this, the emancipation of women in Qatar, which is a real thing. I mean, this is, I would say, unheard of how fast this is happening. If you consider our own history and how long it took for to get voting power, etc. They do everything in 30 years, and now they are almost in that phase that men and women are equally treated, but not completely. So it's still in very much in process, so to say, but you can see it happening, and that we found. Therefore, we found that interesting, and I think also it would need some sort of structure to represent this process. So this is the idea behind it. We did it together with a team from Qatar. There was Yasmin from Jordan, there was Hand from Egypt, and Yamama from Syria, all female designers, like all architects at architect school in Qatar, they're all female. The boys, they study outside, so there are still this discrepancy between men and women, but things are happening, and it's actually the right time to start an initiative like this. So it's now under consideration by Supreme Committee and Qatar Museum, and let's see what comes out of it. It's idea is that it's about 120 meters tall and stands out in the bay of Lucille, which is a new city. And it would look like this from a distance, from the central axis of that city. So here we are, ubiquitous almost everything. I think it's about time to stop the lecture because it takes too much time. I go very quickly through the last points, and then it's open for discussion. About home delivery, I like that very much. Printing on command, everything on command, food on command, production of food on command, peer-to-peer, not to the big warehouses. So basically also that applies to this image. This is a data center in Amsterdam. I'm not so much in favor of this because it's very energy consuming. It would be much better to have a network, a peer-to-peer network from computer to computer, and that can actually do the same thing. So there are a lot of improvements left at these levels, also in banking, in booking. Well, it's too much to discuss on now, but I just show you this image where actually you have the configuration of your space on command. You can configure your own space, and that space is maybe a 50 square meter space in a nice building. And instead of just booking a hotel, you book actually any activity for any length of time in any place. That's the idea. And on the basis of this, it's the idea of that we are new international nomadic citizens, that we want to work anywhere at any time on any project, and less have a stable home basis as usual, but are more free in our doings. And all that would be made possible by simple rules, and complexity emerges out of that. Same for banking. We can do much better than being dependent on the big banks. That are so-called too big to fail. No, they are not too big to fail, but we need an alternative, which is probably very much based on blockchain technology and on peer-to-peer communication, validation of the transactions. So that another normal, to conclude, in my opinion, it's a combination of all of the above. So one single thing wouldn't do much, wouldn't put a dent in the butter, so to say. So you need to work on all levels simultaneously. And I don't think politicians will be very helpful these days. Well, as has been proven in the COP26, nothing came out of it, no real promises. So things really has to be done from the ground up on all levels. So national level, neighborhood level, individual level, and all be connected. And all things and people are connected in very intensive bi-directional networks. I think that was my last slide. So here I end, Laura, and the students are still there, open to discussion.